So let's look at part 3a. So when k equals to 6, show algebraically that f prime x is more than 0 for all x values in the domain of f. So if k equals to 6, you know that this domain here becomes x over k, x bigger than 6. Okay, so let's look at our graph here. If this is 6, so obviously this, you can see that the gradient is always positive. So the whole idea is you want to show that this is gradient is always positive, means it's upward trending when x is bigger than 6. Okay, so that's what we're going to do. So we're going to do this first by part 3a. Okay, so fx is actually just x cubed minus 7x square minus 5x plus 11. Okay, so this case here, I'm going to do is f prime x equals to 3x squared minus 14x minus 5. Now my whole goal here is to show that this is always bigger than 0. This is always bigger than 0 for the domain. Need to show that show f prime x is bigger than 0 for x at least 6. Okay, so how do we show it? I think what we can do is just complete this square here. If you do not know, whenever you see what do you call it, quadratic expression, if you're not sure, just complete the square. Typically is quite clear after that. So x minus 7 over 3 square minus 7 over 3 square minus 5. So this will just be, if you expand this in with 3, x minus 7 over 3 square minus 3 minus 7 over 3 square minus 5. So just going to key in calculator for this part here. Okay, so it's negative 3 7 over 3 square minus 5. That will be 3 x minus 7 over 3 square minus 64 over 3. Okay, so this is my f prime x. Now just take note that the whole goal here is to show that this is positive when x is bigger than 6. So we're going to start off by because obviously this is not always positive, right? Because you know that this graph here will have a negative gradient here. So for 6 onwards, it will have to be positive. So what we're going to do is for when k equals to 6, this is what we need to show. This is not really part of the working, but you can write it. So for when k equals to 6, domain of f becomes 6 to infinity. Okay, so hence x is bigger than 6. We just try and rearrange this so that we get this over here. So you can see that this is minus 7 over 3 both sides. So minus 7 over 3 both sides. What we get is x minus 7 over 3, 6 minus 7 over 3. Okay, so this is like we just minus 7 over 3. Okay, then the next part is to square both sides. So I'm going to square both sides here. Just key in calculator there. 6 minus 7 over 3. Square it will be 129 over 9. So this is 129 over 121 over 9. So it's 121 over 9, and this is x minus 7 over 3 square. After which, what we're going to do is actually just multiply both sides by 3. So multiply by 3. So this is 3 x minus 7 over 3 square. Just multiply by 3, 121 over 9. And we just minus 64. So the whole idea is then just minus 64 over 3. Okay, so that will be this will be 3 x minus 7 over 3 square minus 64 over 3 bigger than 3, 121 over 9 minus 64 over 3. There you go. So this is my f prime x. This just need to key in calculator. So it's 3, 121 over 9 minus 64 over 3. Okay, that will give us 19. Great. So this case here is 19. Of course, this is not the only way to show, but I think this is like easier. So this is more than 0, so hence f prime x is more than 0. It's always positive. Shown. Okay, this is how we show this part here. Then we're going to look at part B.